Okay, so next question related to soil mechanics. For a partially saturated soil deposit at a construction site, water content W is 15%, degree of saturation is 67%, void ratio E is 0.6, and specific gravity of solids in the soil GS is 2.67. Consider unit weight of water 9.81 kilonewton per meter cube. To fully saturate 5 meter cube of this soil, the required weight of water in kilonewton will be dash. Okay, so question asked in 2025 for 2 marks. So let us understand this question. So first of all, it is partially saturated soil. Partially saturated means it is not fully saturated. So we remember that three-phase diagram of soil, that is, the soil will contain some amount of soil solid, some amount of water, as well as some amount of air also. Okay, so the voids will be filled up with partially with water as well as with water and air. Okay, water content, which is also known as moisture content, that is 15%. So in decimal value we can write 0.15. Degree of saturation 67%, that is 0.67. Void ratio is 0.6. So we know that what is void ratio. Void ratio basically is VV upon VS, volume of voids upon volume of solids. Okay, it's this basic definitions we should know. Specific gravity of solids in the soil. Now here we have to be careful. See, they have given specific gravity of soil solids. They have not given us overall specific gravity of soil. It is given that specific gravity of solids. So that's why they have written notation GS. Even though if they are not giving the notation, then also we have to read carefully that they have given specific gravity of soil solids. So that is 2.67. Fortunately, they have given unit weight of water, that is 9.81 kilonewton per meter cube. Even if they have not given, we should know this value, that unit weight of water is 9.81 kilonewton per meter cube. Now the next part of the question is to fully saturate 5 meter cube of this soil, the required weight of water in kilonewton. Okay, so now this 5 meter cube is your actual total volume of the soil deposits. Okay, and that too to fully saturate. Now this is the second case where the soil is getting fully saturated, means all the voids are filled with water. Okay, and in that case, what is the weight of the water? Okay, so I hope we have understood the question. So just I will be solving it. So let us write whatever they have given. I am writing it. Okay, so see, they have given us partially saturated soil deposit. Partially saturated soil deposit, right? Partially saturated soil deposit, we all know that is three-phase diagram. Now here water content, also known as, or moisture content, both are one and the same thing, denoted by W, that is 15%. In decimal we will be writing as 0.15. Okay, now degree of saturation, in some books they are writing SR or S. Okay, both are correct. So that is 67%, or in decimal value it is 0.67. Void ratio E, they have directly given it as 0.6. Specific gravity of soil solids, so that's why GS, that is 2.67. and unit weight of water, of course, unit weight of water, that is gamma W is equal to 9.81 kilonewton per meter cube. So this units we have to be very, very careful. Okay, now the next part is they have asked, suppose for fully saturated soil, for fully saturated soil. Okay, so fully saturated will be converted into two-phase diagram, that is soil solid and water only. Okay, so it is for fully saturated soil, the required weight of water. So we are supposed to find out weight of water for this case. Okay, weight of water dash kilonewton, right? So let us see, this is the given data, and from this data we have to find out the weight of water in kilonewton for fully saturated soil. So let's start with solution. Solution is, see, here we have given this water content, which is initial water content. So let us write initial water content. Okay, I am giving it name, denoting it as W1. So the initial water content is 15%, obviously 0.15. Okay, so for this initial water content, our respective degree of saturation will be degree of saturation. Can I term it as SR1? So it is 67%, means basically 0.67. Okay, so now I am not knowing the final water content, because ultimately I have to find out weight of water. For that I need final water content. So final water content W2 I am not knowing. Okay, but I know that when this final water content, at this final water content, my degree of saturation will be, what will be my degree of saturation? Degree of saturation will be SR2 equal to 100%. Okay, SR2 is 100% means 1.0, because they have asked us for fully saturated soil. So in second case, for final water content, which I don't know, but I know one thing, that for final water content my degree of saturation SR2 is 100%, that is 1.0. Okay, now let us see one formula. Basic formula is E, that is void ratio, is equal to Wg upon Sr. So void ratio is equal to moisture content or water content multiplied by specific gravity, total specific gravity. It's not specific gravity of soil solids. Okay, so total specific gravity divided by SR. Okay, now see, your void ratio, basically void ratio is not changing. Okay, so directly now this formula will be converted into E is equal to, because for saturated condition E is equal to W sat G. E is equal to W sat G. Okay, now I am knowing that the value of E, that E is 0.6. So let's substitute. So 0.6 is equal to W sat into G. Okay, so 0.6 is equal to W sat into G is your 2.67. Okay, so let's find what is W sat. W sat is equal to 0.6 divided by 2.67, so it is 0.2247. okay, so 0.2247. here I have got W sat. So you can see that water content at saturation has increased. It is 0.2247. actual was 0.15. okay, so it has increased. So how much water content increased by percentage, that we can easily find out. Okay, 22.47%. if they have asked that simple, then we can find out 22.47 minus 15%. so whatever will be there, so 22.47 minus 15, so almost there will be rise of 7.47% of water content. Okay, but they have not asked us this thing. They have not asked us how much rise in water content. Basically they have asked us how much weight of water has been increased. So we know the formula of water content also. Water content is W is equal to weight of water upon weight of solid. This formula we know. Okay, but prior to coming to this point, we should know that gamma S, that is unit weight of soil solids, because see we are given GS, so unit weight of soil solid is equal to weight upon volume, weight of solid upon volume of solids. And another formula we know, G is equal to specific gravity is equal to gamma S upon gamma W, unit weight of soil solids upon unit weight of water. Okay, so just substitute this value. So what will be G? G is equal to Ws upon gamma W into Vs. Can I write like this? Now just I have to cross multiply. So weight of soil solid will be G gamma W into Vs. G gamma W into Vs. From this formula just I have to substitute the value of gamma S in this equation. So gamma S is equal to Ws upon Vs. It is nothing but weight upon volume, weight of solid upon volume of solid, that is unit weight of solid. And G is specific gravity is gamma S upon gamma W, unit weight of soil solid upon unit weight of water. Okay, so just by substituting we will get the formula Ws is equal to G gamma W into Vs. Now I know all the values. What is G? G they have given us as 2.67. Okay, so G is equal to 2.67 into, now gamma W is 9.81 kilonewton per meter cube. This we have to remember. Okay, now I don't have Vs. Okay, so for that what we will do, we have one more formula I am writing over here. Vs is equal to V upon 1 plus E. Okay, remember this formula. So V is total volume, that I know, that is they have given 5 meter cube. Okay, so for 5 meter cube total volume, (5) divided by 1 plus what is E? E is 0.6. Okay, so in question only they have given that total volume 5 meter cube. So 5 divided by, let us find out, 5 divided by 1 plus 0.6 means 1.6. So it is 3.125. So 3.125. Okay, so what will be the answer? Ws will be 2. I hope it is visible. 2.67 into 9.81 into 3.125. So our answer is 81.852. Okay, 81.852 kilonewton, because Ws here will everything will be in kilonewton because weight of solids. Now we are not interested in weight of solids, we are interested in weight of water. So here we again we will be using this original formula of water content. Water content is equal to weight of water upon weight of solid into 100. So here I am drawing within a small space. So basically weight of water, now what is weight of water, is equal to small w water content into Ws. Okay, so we are having 2 water content, so we can just find out the difference. Okay, so in second case our Ws is 81.852 multiply by W set. So W set is 0.2247 minus Now weight of solid will remain constant. Okay, so 81.852 into what is the initial moisture content, that is 0.15. Okay, so weight of water, just I have to 81.852 I can take common, so basically I have to just subtract this 0.2247 minus 0.15 multiply by 81.852, 6.1. Okay, so weight of water is 6.1 kilonewton. This is the weight of water. Ultimately I have used this formula. Weight of water, moisture content or water content is weight of water upon weight of solid. So just cross multiply. Weight of water in first case will be weight of solid into weight moisture content. So weight of solid is constant. See, this will not change, Ws will not change. So in both cases I have taken 81.852 into water content. So water content W set was 0.2247 minus weight of solid, again same 81.852 into initial moisture content, that is 0.15. So basically I have to find out weight of water, that is 6.1 kilonewton. So this is the answer. So okay, thank you very much.